We're going to look at the topic 7 mid-topic assessment. So if we go through these, if we look at the first question here, they want us to drag words to show how theoretical probability and experimental probability differ. And it says each word may be used only once. So which probability is based on expected or calculated results? So that would be theoretical probability. Theoretical is based on what we expect. And so then that should mean that experimental probability is based on the actual recorded results. The next question, Stacy uses a spinner with 6 equal sections numbered 2, 2, 3, 4, 5, and 6 to play a game. Which of the following statements is true? So one thing I would probably do on this is I would probably draw a spinner. So it says 2, 2, 3, 4, 5, 6. So select all statements that are true. So probability of the pointer landing on an even numbered section is about 66.67%. So even numbers, if you look at what we got here, we've got a 2, a 2, a 4, and a 6. Those are our even numbers. That's 4 out of 6, or 2/3. And if you divide that out, that'll work. So this is one choice that works on this problem. And just watch, because they actually have kind of underneath is where you got to go above to check it. B, it is impossible the pointer will land on a 1. There's no 1, so that works. C, it is less likely that a pointer will land on an odd numbered section. Odds, there are only 2, and so that's true as well. D, it is certain the pointer will land on a number less than 6. Okay, we got to watch the wording here. If it said 6 or less, that would work, but less than 6 is not a guarantee, so I'm not going to click on that one. And the last one, it is certain. Oh, we just did that one. No, we didn't. Sorry. We got to scroll down here. Okay, and then E says the spinner is fair. So fair spinner means we have the equal chance of getting each thing. You can see we have more 2's here than the other numbers, and so this is not considered a fair spinner. So those would be the answer choices for that one, A, B, and C. So if we look at our next question, looks like we got the same setup, so I shouldn't have deleted my spinner, I guess. So Stacy spins the pointer 120 times, records the results. The pointer lands 30 times on a 2, 19 times on the 3, 25 times on the 4, 29 times on the 5, 17 times on the 6. So how does the theoretical probability compare with the experimental probability of landing on an even number? So the even numbers, if we draw our spinner again, we had 2, 2, 3, 4, 5, and 6. So getting an even number, options there would have been 2, 2, 4, and 6. So we already said that in the last problem. That's 4 out of 6, or 2/3, which was about 66.7%. Experimental for even numbers, 30 times they got a 2. Even numbers, so 25 times they got a 4, and 17 times they got a 6. So if you add those together, that's 72. And it said they spun 120 times. So we're going to look at 72 divided by 120. And that's 0.6, which means 60%. So we were expecting about 67%. We actually got 60%. So it says the blank probability is greater. So theoretical probability is greater than experimental. And we can see from how we worked that out, the experimental is 72 out of 120 and theoretical is 80 out of 120. Now I didn't actually work that part out. If you wanted to, you could figure out of 120, that'd be times 40. 2 times 40 is 80. But otherwise, if you just go by the percents, from the percents, you should be able to tell which one has a greater or less chance as well. Look at question 4. Does the following list represent a complete probability model, and explain? So complete probability model lists all the different options. So the probabilities should add up to 1. So if we have 1/6, 1/3, 1/12, and 1/2, the question is whether those add up to 1 or not. So we're going to try to add these together. To add these together, we would need to get a common denominator. So 12 could be our common denominator. So then our new fractions, we would have 2/12, 4/12, 1/12, and 6/12. And if you add those together, 2 plus 4 is 6, plus 6 is 12, plus 1 is 13. So we got 13/12. That's not possible. So this is not going to be a complete probability model, and let's see what the reasoning is. First option says no, the product of the probabilities is less than 1. Product would mean multiplying. We're not multiplying, we're adding. B says no, the sum of the probabilities is greater than 1, and that's the answer that we want. And if we look at the last question here, question 5, Rachel plays a game by rolling 2 number cubes with sides numbered 1 through 6. To win the game, the sum of the numbers facing up must be 11. What is the probability that Rachel will win the game? So she's rolling 2 number cubes, 1 through 6, and to win, the sum must be 11. You had some tables back in your book that listed some different options, and so you could look at those. If you think about it, a sum of 11, the only way we could get a sum of 11 would be if we roll a 5 and a 6, or if we roll a 6 and a 5. And if you go back and look at that table in your book, or you could recreate the table yourself, that's 2 out of 36, or you could reduce that to a 1 out of 18 chance. The answers that they gave here, they actually didn't reduce this, and so they have 2 out of 36. So 2 out of 36 would be the answer for that problem. So this gives you an idea of what we're looking at for the Topic 7 mid-topic assessment.